Hello everyone, welcome to another episode in this week of Video Geeks. I have with me Anil Mistry and an expert, Ayush Mansha, with us today. So Anil is currently presenting his screen right now. Hey, what's up guys?
Yeah, hello Dev. Thank you for the introduction. And I'm fine. What about you? Are you all good?
Yeah, I'm good as long as there is AI.
Oh, that's a cool thing. Yeah, that's for sure because AI is reducing so much of work. So
Yeah,
now let's move on to today's topic that I'm going to present today.
yeah, sure.
So, yeah. So in the last video, as the audience might not remember, so for the viewers who might be first time on this channel, Video Geeks and all that stuff, for them I would like to just revise that in the last video we have seen how to configure port channel and the detail like what are the packet exchange and how it will form port channel and all that stuff, right? So you might not get this MLAG if you are not aware about the port channel, because MLAG is totally dependent on port channels. So I would highly likely suggest for the viewers like who have not watched the previous videos of port channels, for them I'll put the link of those videos in the description. Just watch this video and then come back to this video, okay? So today we'll talk about MLAG. So this is the first video in this MLAG series, and this is the continuation of after the port channel. And remember all these three things that we have seen. First was STP, then there was port channel, and then sorry, let me just reframe it. So first we have seen the STP, then there was one problem, and for that solution we have seen how port channels can be used. And now we are aware about the limitation of port channel, that it cannot extend, we cannot form port channels, uh, let's say when we have two separate devices connected to one switch. So that was the one limitation, and to overcome that we, we will we are going to see MLAG. So let's just start about this. So this is the introduction. We'll give you the overview of MLAG. So we'll discuss that why we need MLAG by taking an example of what was the limitations of LSCP. And remember, LSCP is link aggregation control protocol that we have seen in the last videos. We'll see about how to overcome and how to trick the LSCP. The same way, not the same way, but actually we have tricked the STP and form the port channel, right? So we'll here trick the port channel and form the MLAN. So you see how these videos are connected and how these protocols are connected. So that's why I highly suggest that please watch the previous videos. Then after we'll see the requirements of the MLAG for on Arista, right? So I'm making it why I'm making it like vendor specific, that I'll talk later. And we'll see basically all about the MLAG. So let us just think that why MLAG, like why we need MLAG. So we'll talk about redundancy. In terms of redundancy, what the port channel was having. Let's say uh, we have one link only from this switch to this switch, and if let's say one that link goes down, because that's a physical link, and physical link are what you can say, uh, exposed to environment melodies, and it can be broken down due to some physical damage or something, and it can go down. So in terms of that, we have introduced port channels. So that will basically group multiple ports to form port channel between two devices in such a way that it will form a logical port, which is a bundle of multiple physical ports. So that way it will introduce redundancy. So if one of the ports inside that port channel goes down, then also there will be a connection from these two devices, because there are other ports that can handle the traffic. So that was the redundancy that we were getting if we have configured the port channel. Now just assume what happens if the one of the switch goes down. Then what's the point of these port channels? All the ports are become let's say useless, because This one of the switch, if that goes down, then all those ports that cannot be used, because those are connected to the device which is not working. So uh, what we can do over here? So redundancy is not at all, or what you can say, really compromised, or we need to look something for the good, right? What if one switch fails? So there is no point of having port channel in case of device failure. So that's why we have something MLAG. So let us just now talk about the requirements. So remember, these are the requirements of LSCP. So as we have seen in the last video, these were the requirements. So the first requirement was like grouped port should be connected to the same switches, right? So how it goes, like when we form a port channel, the switches will exchange their switch, what you can say, switch ID. So let's say these two ports are connected on the same switch, and from these two, both of these ports will receive the packet with the same switch ID. So we can come to know that yes, these two ports are connected to same switches, and it can form a port channel. So that's how port channel internally works. So it will, that way it will make sure that both of all of the ports that are in one port channel, they are all connected to same switch, and they will verify it using switch ID. So that way, if let's say switch is connected to two different switches and we are trying to form a port channel over here, there will be one switch ID coming from here, and there will be different switch ID, as this both switch have different switch IDs, because switch IDs are generally combination of MAC address and priority. So they, both devices will have definitely different MAC address, so different switch IDs, and that way port channel will not form, because both of these ports are receiving packets with the different switch IDs. So we can trick the what you can say, port channel over here, and how, that we'll discuss in the next slide. So this is all about the trick. So we can configure MLAG. MLAG configuration will select one primary switch, and only the primary switch ID will be exchanged with the uplinks. So remember this stuff that I have mentioned over here. And also, I would like to bring you one attention over here, that if you have remembered that how we did the trick to what you can say, STP, that to form a port channel, we have introduced something like port channel. So by making sure that these two ports will appear as same one logical link, we have created port channels. So that way we have what you can say, tricked the STP to treat both of these ports as same ports, and then this STP will not came to know that this is a loop. Otherwise, it would have detected that these two links are forming a loop, and one of these links would have gone like blocked. So that way we have tricked the STP. Now about the port channel, we have just talked about that, how we cannot form this port channel because they are both connected to different switches. So how we can configure the MLAG? So usually how the MLAG is configured, it is like this. So just forget about this switch, the first one. Just assume that we have these two switches, and remember, for the MLAG, we definitely need port channels to be configured first, right? So let's say this is the port channel that we have configured on these switches. And now let's say we introduce one switch and we have connected both of these switches. So we'll configure MLAG on these two switches where we have configured the first port channel. So these, I'm just telling you the steps. And then what we will do, there will be one of what you can say, MLAG will choose one of this switch as primary switch, right? And if let's say packet is received on this switch, so by communicating via MLAG, the switch will have primary switch ID configured on both of them. So let's say this switch is primary switch, then ID of this switch will be configured, or you can say will be saved over here on this switch after the successful configuration of MLAG. And let's say there will be an LSAP negotiation packet that has been received on this port while forming a port channel. Also, this switch will receive the same. In that case, the packet will only carry the switch ID of the primary switch, because now they are in MLAG. So they will send the packet with the same switch ID, and that way we can take the port channel and actually we can configure the MLAG. So that is the way of how we can trick the protocols, right? And now let's talk about the very basic requirements to configure the MLAG. And remember, MLAG is the Arista specific term. So on all the Arista switches, Arista devices, you will get that feature, or you can say protocol, as MLAG. But in Cisco devices, it is known as virtual port channel, VPC. And these are the requirements for the Arista switches only, right? So let's talk about that. So the first requirement
So,
is,
hey,
yeah,
sorry for interruption, but you just said that this term for Cisco and Arista is different.
yeah, yes, yes, for sure.
Can you elaborate on that? Like,
Yeah, I have something
okay,
kept on.
what's the basic, what's the fundamental concept? And okay,
Yeah,
basic, go on.
okay. So MLAG that we are talking about, the this port, you can say feature, or you can also consider it as a protocol. So that is not the standardized protocol. That we'll discuss that. Uh, uh, the MLAG, or multi-chassis link aggregation, that is vendor specific or proprietary protocols that individual vendor provides. So MLAG is a feature that is provided by the vendors. That's why the vendor have access to change the name, but there is no such standardized protocol. So LSAP is standard IEEE standard protocol. So LSAP will be same like the name on both all the vendors, across all the vendors. But as this is not the IEEE standardized protocol, that's why it has different names: virtual private, virtual port channel. Sorry, not private, virtual port channel, NAMLAG. I have kept
Oh,
something on. Yeah,
okay. I guess that's why I see RFC for LSCP and not for ML.
MLAG. Yep, yep. You will not find any RFCs because MLAG is not IEEE standards protocol.
Yeah, yeah, that's clear. Thanks.
Okay. I have kept something on the uh, next slide. Just some facts or some things to know about the MLAG before diving into it. So we'll also look into that. But before that, let's just see what are the requirements to configure MLAG. So this is for the once more, this is for the Arista devices only. So the first requirement goes like, they must have similar or compatible EOS versions. So EOS is like the operating system of all these devices that you can find on the Arista store or Arista devices. So all the Arista devices will have OS, EOS, and that is the revolutionary technology of the Arista that I'll explore someday in the future. And another requirement goes like, same interface configuration on peer switches. Now peer switches you might know, not know, but the switches on which we have configured the MLAG, they both are called peer switches. And MLAG will, what you can say, uh, when we have configured the MLAG, so these both switches will appear as single switch, single logical switch to this switch. Now this is the slide that I was talking about. So there are some things that we need to be aware about before diving deep into the ML. So let's just talk about it. So the first thing is, a lots of customers use these dual homing devices. Many customers use this when, let's say, they have this kind of dual connectivity and they want to introduce redundancy between these two switches. So if we have configured MLAG and any one of this switch will goes down, then also we'll have connectivity. That's because we have configured the port channel and MLAG. So MLAG, LSCP is redundancy uh, on the physical ports, and MLAG is the redundancy between two devices. So if let's say one of the devices has went down or goes down due to some reason, then also this device will be operational, and we can send our traffic through these devices. And in the LSCP we cannot do that, because let's say one of this switch goes down, then we cannot utilize the port channel. So another thing is, it is not a IEEE standard protocol, as we have talked about. So MLAG is the vendor specific protocol. Many vendors will have different names. So yeah, it is a vendor specific and proprietary. So MLAG is the proprietary protocol for the Arista switches, and it is also known as VPC or virtual port channel for the Cisco devices. So you will see virtual port channel, or you can configure VPC the same way we configure MLAG on the Arista switches. And it relies on port channel for LS or at the LSCP. So that is must you need to be aware about. So for configuring MLAG, you must have to be configured port channel, or your devices must support the port channel or LSCP. And some of the components that we will use to configure the MLAG, and for these terms we'll also use when in the second video when we'll see how to configure the MLAG. But just to let you know, these are all the components. Peer switches.
Yeah.
So as we have talked about, uh, yeah, you want to say something, Dev?
No, no.
Okay. So as we have talked about, the on these switches, when we want to introduce the redundancy and where we have configured the MLAG, so these both two switches are called peer switches. MLAG domain ID. So basically, we'll configure the domain between two switches, two peer switches. That is known as MLAG domain ID. And other is peer link. Peer link is like the port channel that we have configured between two peer switches. So that is known as peer link. And peer address, so that is relative term. For this switch, the IP address of this switch for the communication, that is peer address. And for this switch, the IP address of this switch for which is used in the MLAG communication, that is known as peer address. So that's basically it for the MLAG basics, and that is the end of session 1 for the MLAG. We'll explore more about MLAG and how to configure it in the upcoming session. Any questions?
Really great coverage of MLAP.
MLAG.
Yeah, MLAG.
Yep. So yeah,
Yeah, so
hopefully
since you have covered the vendor protocol for Arista, what's the similar for Cisco?
that is virtual port channel VPC. Small
Oh,
V, then there will be PC, virtual port channel.
okay. So implementation wise, both are same or
Yeah. So there is just a minor difference in the command line arguments, or you can say how we configure it, the actual commands. Other than that, all the MLAG components and how the protocol internally works, that is same for the Cisco and for the Arista also. Just the way they have named it, that is different.
yeah, the setup is different. Fundamentals
Yep.
would be same. Yeah,
Yep.
yeah, great video. Thanks.
Yeah. And for the audience, hopefully you have got the idea about MLAG. We'll see you in the next video with the MLAG, how to configure an MLAG in the session 2. Till then, keep learning, keep exploring.